All right. So in the first class of the extrusion process, the idea was to build a base. I know you know what is in extrusion, but now everyone is at the same page. In the second class, the idea is a bit different. Now I will start going deep into each part of the extrusion process. And the first thing that I want to talk is the condition. And I will go from the basic and I start giving tips on how to improve, how to increase capacity. So let's do it together, right? Conditioning. Remember that I said that the extrusion process is a two-step process. First step is conditioning, second step is extrusion. And if we make an analogy, the analogy would be if you're cooking, the conditioning process would be a pan on top of a stove. The extrusion process would be a pressure cooker. Why is that? Because at the conditioner, we cook at ambient pressure. In the extrusion process, we use pressure. We use pressure to cook our product and to create our product. But what is the objective of the conditioning process? We have three main objectives. First objective is to improve pellet quality. We want to improve pellet quality, and to improve pellet quality, we need to cook. And that's what the conditioning process will help us. In the conditioning process, we're going to start adding steam and we're going to start adding water. So when material goes from the extruder, from the conditioner to the extruder, the material is ready to be processed, right? We are not trying to process dry material at the extruder, right? It will be much harder to process dry material. And that goes the second objective, which is reduce motor load at the extruder. It is much easier to process a material that is moist, a material that is hot, a material that is soft, than to process a material that is dry, a material that is hard, a material that is cold, right? So you can see how the conditioning process plays a very important role over here. And that is linked to the third objective, that is reduce wear at the extruder. If you're not properly conditioning your product before the extruder, what's going to happen is that this material will fall and will be processed inside the extruder, and this material will be, like I said, will be dry, it will be cold, and therefore it will be much harder to push this material forward along the extruder. And if it's much harder to push this material forward, it means that your extruder motor is doing much more work. And if the extruder motor is doing much more work, it also means that it will wear your parts faster and will reduce your extruder capacity. And this is not what we want, right? So we need the conditioner to improve your process in all these ways to get a better product, to improve your quality, to reduce your extruder wear, and to increase your extruder capacity, right? And how does it work inside the conditioner? The conditioner will do three things at the same time. It will mix and move the mesh forward. So we have mesh falling inside the conditioner from the fitted screw. This mesh is going to be mixed and is going to be moved forward by the pedals. Pedal will do that. The pedals will mix, the pedals will make your mesh moving forward. The second thing that will happen at the exact same time is you're going to inject water. And what water will do? Water will moisturize your mesh. And that's the first step to start cooking it, right? So you need water to cook. It's like in your kitchen, you need water to cook rice, right? It is the same analogy here. And the third thing that will happen at the same time is we're going to inject live steam inside the conditioner. Live steam will increase your mash temperature from ambient 15 to 20 degrees to 95 to 99 degrees, which is going to make that mash very hot. And like I said in the previous classes, inside the mash that you're processing, you have some amount of starch. usually between 15 to 22 to 25%, no more than that. This starch is the glue for your product. If you don't have enough glue, if your starch level is below 13%, what can happen is your product will be more fragile, right? But it's not just about how much starch you have, it's how much starch you're actually using. And to be able to use this starch, you need to activate this starch. And to activate, you need to heat up this starch, right? So starch, like I said, it can come from different sources. It can come from wheat, it can come from sorghum, it can come from corn or whatever raw material you're using. But you need to activate. And how do you activate? You heat it up. And this image shows just that. On the left hand side of this image, you have pure starch, right? Increasing the starch temperature. So over there, you can see that we are heating up at 80 degrees. And after some time, you see that this white material start becoming transparent. And it's becoming transparent because we are cooking it, we are activating it. And once we open the bag, you see that looks like a glue because it has transformed itself into a glue. That's going to be the glue for your product. So again, when we look at the whole process, we have the live bean, we have the feeder screw, we have the conditioner, and from the conditioner, it falls into the extruder. And the first advice that I want to give is feeder needs to deliver product at a constant rate. If the feeder is fluctuating the amount of material that is being transported into the conditioner, what's going to happen is that your product quality will vary. You're going to have short or low pellets, your density will vary, the pellet quality is going to fluctuate. But what I want to do is start looking inside the conditioner. And when we look inside the conditioner, we see that inside the conditioner, we should have something like this. So if we look at this picture, what we see pedals that move the mesh along the conditioner towards the extruder. And you can imagine that the material will stay inside the conditioner for some time. And this minimum time is 2 minutes. This means that from the moment the material enters the conditioner, that material should stay at least 2 minutes inside the conditioner before it falls from the conditioner into the extruder. All right, but how do I measure that? There's a way to measure that, but your supplier already knows that. And the conditioner is designed for that. What we need to guarantee, therefore, is that we have the right level inside the conditioner. Because if the conditioner is too empty, what's going to happen is that you're going to have steam that will escape from the conditioner, right? Because you're going to start adding steam and you don't have this barrier that is made of material to hold the steam inside the conditioner. Therefore, your steam will start escaping. Okay? You also will have poor mixing, and this is not what we want. But we also can have the opposite. If the conditioner is too full, then we're also gonna have poor mixing because the conditioner is gonna be so full that the pedals won't be able to mix properly. And you can see lumps of product leaving the conditioner if the conditioner is too full, which means that we're gonna have uneven cooking because part of the mash is gonna receive water, part of the mash will receive steam, but they won't be properly mixed, right? And that can also make your product vary at the extruder. This is what we want. We want the conditioner half full. So if you press, if you press the emergency button at your extruder and you open the conditioner, right? So everything has just stopped. You open the conditioner. This is what you need to see. You need to see mesh at the shaft level. That's what we want. If the mesh is at shaft level, we know that we are operating at the correct filling degree inside your conditioner. All right, next thing. we need to inject water. Water is the first thing that we're going to inject inside your conditioner. But it's not just about injecting water, it's how to inject water. It's how to inject water. Water is going to use to humidify the mash, but you need to use spray nozzles. These spray nozzles are going to pulverize the water, and we need that small drops to guarantee that every piece of mesh receive the same amount of water. Imagine the opposite. If you have a stream of water, if you don't have nozzles and you have a stream of water, part of the mesh is going to receive a lot of water, part of the mesh is going to be dry. And even though you have pedals that will try to mix everything, you won't be able. You won't be able to mix everything. The pedals won't be able to compensate this poor water injection. So you want to have many nozzles of water along your conditioner to inject water, to spray the water on top of your mash. The same concept goes for oil and other ingredients that you want to inject. The only difference is that oil you're gonna inject at the far end of your conditioner, and water is gonna be the very first thing that you add in your conditioner. And again, it's not only about injecting water, but also you need to know how much water you're injecting. In a very basic operation, you need to have a measuring instrument to know that how much water you're injecting. That's important because you want your first shift operator to be adding the same water as the second shift and the third shift operator. All operators need to do the same. You cannot have one operator doing one thing and the other operator doing a different thing to produce the same product. The second thing is just by measuring, you know what's happening. If you're not measuring, if you have fluctuations in the amount of water that you're injecting because of some problem in your water pipeline, if you're not measuring, you cannot capture those problems. You cannot see those problems. The problems will just happen and you won't be able to know why that problem happened. So you need those instruments to measure how much water you're injecting. In the best case scenario, it's not just water, it's hot water between 55 to 60 degrees. That's optimal. And why is that? Remember that I said that you have starch and you need heat to activate the starch? If you inject water at ambient pressure, you'll waste some time inside your conditioning process just to take the material from ambient temperature to 55, 60 degrees, which is the temperature where we start activating the starch. Now, if you inject hot water already at 55, 60 degrees, from the moment that hot water hits the mash, it already starts activating the starch, which means that hot water have a similar effect as having a larger conditioner. I have seen factories where they made investment, a very expensive investment to install larger conditioner when they could only make a very small improvement of using hot water. Water should always go from the top of the conditioner. And why is that? Simple as gravity. Gravity will make water fall from the top to the bottom, which means that if we add water from the bottom, water will stay there. And we want the opposite. We want the pedals will push the mesh up while we inject water from the top, right? Moving from water to steam. Steam is the opposite because steam travels up, which means that if we inject the steam from the top of the conditioner, this steam will just escape. And this is not what we want. That's why steam will always be injected from the bottom of the conditioner. Because when we add steam at the bottom, the steam will hit this barrier that is made of mash and will start increasing the mash temperature. And only a small portion of steam will escape. So to summarize, water from the top, steam from the bottom. We also need steam at the correct pressure. Steam needs to be injected between 1.5 to 2 bar maximum. So steam is coming from the boiler at 8, at 10 bars. And we're going to reduce the pressure down to 1.5 to 2 bars. Why we do that? We do that because if we inject steam at 5 bars of pressure, steam has so much force, so much pressure that steam will just go through this barrier of mesh and leave. It will heat up, it will, but you will also waste a lot of steam. A lot of steam will just escape from the conditioner, and this is not what we want. Steam is expensive to generate, so we need to use steam very wisely. We cannot waste steam. And to not waste steam, we need to reduce the steam pressure at the conditioner. And then, like I said, you're gonna use steam. Steam will heat up the mesh, and when material leaves the conditioner, that material should be between 90 to 99 degrees. It cannot be less than that. Less than that, we start having problems at the extruder. We start sending cold material at the extruder, which is gonna cause all sorts of problems like we mentioned. You're gonna have more wear, you're gonna have less capacity, and if it's more than 99 degrees, it means that we are not measuring the, we need to measure the temperature of the mesh that is leaving the conditioner. So like in this picture, we need to place a thermometer at the far end of your conditioner, and this thermometer will sense the temperature of the mesh that is leaving the conditioner. And there's two ways of controlling the temperature of the conditioner and controlling how you inject steam. First way, very manual, is you have a temperature sensor at the far end of your conditioner. The operator opens the steam valve at the steam manifold, and as the operator opens the valves at the steam manifold, you inject more or less steam to reach the temperature that you want. So if you're aiming for 95 degrees, operator opens the valve. If it's reaching 97, which is more than 95, the operator closes a bit the valves. It will reach 93, which is less than what we want. The operator opens the valves a bit more. Keep doing that just to reach the temperature that we want, right? So operator opens the valve, temperature increases. Operator closes the valve, temperature reduces. But of course, we can automate that. And that picture shows just like that. So in this picture, what the operator have asked is temperature of 95%. And the automation system has opened the steam valve at 82%. 82% is giving a temperature of 95.4 degrees, which is pretty much what we want, right? So what the system will do automatically is all the time, every single second, look at what temperature do I have, what temperature do I want, and keep the loop. So like we have over here, the temperature is a bit more than what we want. So the system will automatically close the valve just a bit to reach the 95. As temperature goes down, when it goes below the 95, system opens the valve just a bit more, just to reach the temperature target, right? So we'll continue doing like that. And that will guarantee stability in our process. We cannot have temperature vary. You cannot have temperature at 97, then at 95, then at 93, back to 97, and fluctuating like this. We want a temperature very, very stable. And this is possible if you have a system like that. So that's a very easy automation, that's a very basic, but it is worth it. You just need a pressure valve to reduce the steam pressure from the 8 bars that you have in your boiler down to 2 bars. And after the pressure valve, you're gonna have a proportional valve. that is going to control the amount of steam that you're injecting inside your conditioner to reach and to maintain your temperature at the temperature target. And this setup also makes the operator's life very easy, because if the operator see the opportunity to improve the product, to improve capacity by moving from 95 to 96 degrees, all he has to do is to type the new temperature target inside the automation system. He doesn't need to play with the valves. So imagine that the operator went from 10 tons an hour to 11 tons an hour, right? You have more material coming in with the same amount of steam, temperature will fall, but he doesn't need to touch any steam valve, because the automation system will understand that he needs more steam to keep the temperature inside the conditioner at the temperature target. It will naturally open and adjust the amount of steam. So you see, everything is automated. So with this, I finish the first conditioning class. I have another class about the conditioning process. So if you have doubts, just shoot an email. If you don't have doubts, just go to the next class, because over there we're gonna give more tips, more things that you can implement to improve your production process. So let's go to the next class.